Welcome to the Copperfield Electric Podcast. Today, we are taking a deep dive into an issue that is, well, it's silently affecting the functionality, the safety, and even the future value of millions of homes. We're talking about that critical decision to upgrade your home's electrical service from the old 100 amp standard to the 200 amp modern necessity.
And our mission today is pretty straightforward. We're going to extract the essential knowledge you need about panel capacity, safety compliance, and, all those future electrical demands. We're using insights from the article, Boosting Electrical Capacity, the 200 amp service upgrade, and, of course, the practical day-to-day experience of Copperfield Electric to give you a clear roadmap.
Okay, let's unpack this. Before we get into the nuts and bolts of the upgrade, let's frame where this expertise is even coming from. We're leaning on the knowledge base of Copperfield Electric. They're a family-owned, licensed, bonded, and insured 24-hour service, and they specialize in some pretty complex electrical infrastructure all throughout Southern California.
Right, and specifically, they're concentrated right in that high-demand region of Orange County. So they're serving areas like Irvine, Anaheim, Santa Ana, Newport Beach. And this geographic focus is really key because, Southern California homes, they're pushing electrical demands to the absolute limit. Think about all the air conditioning use and, crucially, the massive adoption of electric vehicles.
Oh, absolutely. The need for capacity there is just intense. And their service list really confirms this. They handle complex electrical panel upgrades, replacements, but also other high-demand stuff like new construction wiring and, maybe most relevant for us today, dedicated EV charger installation for both homes and businesses.
Yeah, it creates this perfect feedback loop of knowledge. They aren't just reading about capacity issues, they are actively solving them daily, 24/7. For customers dealing with everything from a trick breaker to, installing a brand new Tesla Powerwall. And they have a 100% guarantee on that work, and all that experience really forms the foundation of our discussion.
So let's get into the why. For decades, 100 amp service was like the golden standard. If you think of electricity like water flowing through a pipe, 100 amps was a perfectly good pipe size. So why is that same pipe size now causing a flood of problems?
It's a classic case of what you might call technological creep. When a lot of these homes were built, say back in the 60s or 70s, 100 amps was more than enough. You had a refrigerator, maybe one window AC unit, a washer, some incandescent lights. Your peak load was just minimal.
And now?
Oh, wow. Now every single room has multiple charging devices. You've got huge LED screens, high-powered hair dryers, maybe a tankless water heater, a massive central air unit, and on top of all that, maybe an induction cooktop. And if you're in a dense area like Orange County, you are very, very likely looking at installing an EV charger, which alone can draw 30 to 50 amps for hours at a time.
That's incredible. It's like running a miniature air conditioner at full blast in your garage while you're also trying to cook dinner. So if your service is only rated for 100 amps total, you're trying to squeeze 150 amps of demand through a pipe that was only designed for 100.
Exactly. The 100 amp service is simply overwhelmed. It's like trying to run a marathon on a diet of crackers. It can't sustain the energy output.
Okay, so moving to 200 amps is about providing a wider pipe.
Let's talk about the tangible benefits that the sources really emphasize. Beyond just, it works better. What are the three main advantages of doing this upgrade?
Well, the first one is the most obvious one. It's increased capacity. And this is really about peace of mind. You get enough power to run all your modern devices at the same time without having to play that electrical shuffle, turning off the oven to run the dishwasher. Yeah, I know that game. The second benefit, and this is one I think really justifies the cost for a lot of people, is future-proofing.
Yeah.
You mentioned ADUs and EV chargers. If a homeowner has a 100 amp service and they decide to install a solar array or an electric car charger next year, they're going to hit a wall. Upgrading to 200 amps now just means the system is ready for that next wave of technology.
And the third, which is frankly the most critical one for a homeowner's safety, is the dramatic reduction in electrical issues and hazards. An overloaded 100 amp system doesn't just annoy you by tripping breakers. It leads to sustained overheating in your panel, in the wiring. This causes premature degradation, power surges, and in the worst cases, a real risk of an electrical fire. The upgrade actively mitigates these severe hazards by making sure the system operates well within its safe limits.
That last point is so crucial. It really is the difference between a minor annoyance and a major insurance claim.
Absolutely. The sources make it very clear. Safety compliance is often the non-negotiable driver here.
And this is where it gets really tangible for you, the listener. If you're living in a home built before, say, 1990, you are probably running on a 100 amp panel. So how do you know definitively that you need to call a professional for this? we've distilled the 4 big telltale signs.
Okay, so sign number 1, and this is the most common complaint that Copperfield hears, is frequent circuit breaker trips. Now, we're not talking about tripping a breaker once a year because your toaster went bad. We mean tripping a main breaker or repeatedly tripping a circuit every time you try to use the microwave and the hairdryer at the same time.
And the key distinction here is that the breaker is actually doing its job, right? It's preventing a fire. But constant tripping is your 100 amp panel just loudly signaling that it's exhausted.
Precisely. If a breaker is tripping often, it's usually not the breaker that's the problem. It's the lack of sufficient capacity upstream in the main service. A 200 amp service just accommodates that higher amperage draw across all your circuits without constantly hitting that overload threshold.
Let's move to sign number 2, which should trigger immediate alarm bells. Electrical fires or sparks. If you open your main panel box, or if you see charring or smell smoke or burning plastic near the panel, that is a catastrophic failure in the making.
That smell is the insulation on the wires literally melting from sustained overload. It means the circuits are too hot and the safety mechanisms either aren't working fast enough or the problem is right at the main connection itself. The source material really emphasizes this is a major fire hazard. You need an upgrade to comply with modern safety standards immediately.
Okay, move to sign number 3. Older homes with outdated wiring and components. A lot of homes that have 100 amp panels also have outdated systems behind the walls too. Older, maybe less reliable materials.
That's the structural issue. It's not just the box on the wall. It's all the components leading up to it. In older installations, the service cables, the ones that run from the utility meter to your panel, they might be old aluminum or copper that's only rated for 100 amps. They are simply not robust enough for what we demand today. Upgrading the panel allows an electrician to modernize that whole service entrance system.
And sign number 4 really speaks to lifestyle and just planning. It's increased electrical demand. This is the forward-looking sign. Even if you aren't tripping breakers right now, if you're planning on installing specific high-draw items, you mentioned central air or an EV charger, you are effectively guaranteeing that your 100 amp limit will be breached.
Yes. Just think about those additions. An EV charger alone, let's say it's running at 40 amps.
Yeah.
That consumes 40% of a 100 amp service by itself. Add in the kitchen, the lights, the AC running on a hot Southern California afternoon. The math just doesn't work out. The upgrade becomes a necessary precondition for that new appliance.
So we've established the symptoms and the diagnosis. Now for the logistics. This is not a simple appliance purchase. If a homeowner recognizes these signs, what's the actual highly regulated 4-step process for upgrading to a 200 amp panel?
It's highly regulated for a good reason. You're dealing with the main electrical supply to the house. So step 1 is assessing electrical needs. A licensed electrician needs to perform what's called a load calculation. They don't just guess. They analyze the square footage, the number of circuits, your planned future loads, like that EV charger, to confirm that 200 amps is the right level.
Okay, then step 2 is the actual work, replacing the existing panel. This is where the old, smaller 100 amp box is taken out and replaced with the new, larger 200 amp panel. And I imagine this new panel might need more physical space, and the electrician has to make sure all the wiring complies with current local codes.
Right. And then comes step 3, and this is the part that homeowners often underestimate, upgrading the service cables. We touched on this. The service cables are the main artery running from the utility connection to your new panel. If they were sized for 100 amps, they must be replaced to safely carry 200 amps. This can involve coordinating with the utility company and sometimes even trenching to replace underground lines.
Wow, that sounds like a massive logistical bottleneck. Is that why the cost can swing so wildly?
Oh, absolutely. That is the key. The panel swap itself is relatively contained.
Right.
But replacing those service cables, especially if they are buried, that involves permits, potential utility downtime, and a lot of labor to pull thicker cables. It fundamentally changes the cost calculation.
Which I guess brings us to the final step. Step 4. Inspection and testing. After all that physical work, a local building inspector has to come out and sign off on it. And this final check ensures that the new panel and all the cables are functioning correctly and safely.
Exactly. It ensures compliance, safety, functionality. And it confirms that you have indeed purchased a full 200 amp service, not just a 200 amp box.
Let's talk about the money, because this is often where a homeowner might hesitate. The typical financial commitment is cited as being between, $1,500 to $3,000? That's a pretty significant range. What's the $1,500 version and what's the $3,000 plus version of this job?
The lower end of that range, so the $1,500 to maybe $2,000 mark, that usually covers the simpler swap of the panel itself. That's in a home where the service cables and the meter box are already in decent shape, or maybe they were recently updated. This is rarer in true legacy homes.
I imagine the higher end, so near or even above $3,000, that has to cover the complexity of those service cable upgrades you mentioned.
Correct. The most significant cost driver is replacing those feeder cables or performing extensive wiring upgrades to meet current code, which often gets unearthed during the process. If trenching or major work around the meter is needed, that budget can be stretched considerably higher.
So if I'm a homeowner who sees those sparks, I need to understand that this isn't just an expense, it's mandated safety. It's functional infrastructure.
Exactly. And that's why the final recommendation from the experts at Copperfield is always the same. Consult a licensed electrician for a comprehensive on-site estimate. They need to assess the specific condition of your service entrance, that cable bottleneck we talked about, to give you a really accurate picture of the investment required.
It's an investment that pays you back in safety, load capacity, and just avoiding the constant headache of overloaded circuits.
So, to synthesize our core findings here, upgrading to 200 amp service is really the modern standard because it provides that essential increased electrical capacity that 100 amps just cannot deliver. But more importantly, it significantly reduces the risk of serious electrical hazards like fires, and it's the single best way to effectively future-proof your home against additions like ADUs and EV charging.
Which brings us to our key takeaways for you. If you are constantly tripping breakers, or if you're planning any high-load addition, a new AC unit, or especially an EV charger, the 200 amp upgrade is framed by the experts not as optional maintenance, but as a critical, wise investment in the immediate functionality and the long-term value of your property.
And this leads us to a final provocative thought for you to consider, especially when you're looking at those cost estimates. Since the process of upgrading a panel often forces you to replace those crucial service cables, and since that cable replacement is typically the most expensive and disruptive part of the whole job, when you're planning for a panel upgrade today, how much capacity should you plan for beyond your immediate needs? Should you consider making the leap directly to 300 amps or even 400 amps now if it's available, even if you only need 200 today? Because digging up those external service cables again in 15 or 20 years when capacity demands inevitably rise might cost a fortune. That question about planning for a 50-year horizon, not just a 5-year one, that is perhaps the ultimate way to future-proof your electrical infrastructure.